Hey guys, this is Steven from LegitTechTutorials and welcome back to my product design series. Today we are back looking at the smart charger, designing the smart mixed chemistry lithium, mainly built for LiPo charging, lithium ion or LiPo charging. So I just got in the if you guys remember from my last few videos, I just got in my digital potentiometers. So they just came in from the boat from China, and they look pretty good. Everything on them looks pretty well soldered and pretty straightforward, it looks like. Yeah, so we are going to be continuing to lay out our project in Illustrator, and with that we will have everything set to go and wire colors picked out, and also figure out if we need any extra components, which I believe we're probably going to need some sort of buck converter that takes anything that you throw, any voltage you throw at it, and converts it down to 5 volts to power all the logic of all this stuff. So we're probably going to need one of those, or use one of my but that's a maximum 12 volts. The power supply I'm going to use is like 14. I could use a, I have a whole bunch of these motor drivers, so maybe I'll just use that in the meantime as a buck converter, or maybe I'll just buy a cheap buck converter off the web that will take anything between 0 to 24 volts or above and convert it down to 5 volts. Or I could use a wall wart, which I have a whole bunch of them that can do anywhere between 5 and 12 volts. Or I could just power it off of well, no, because I'm going to power a whole bunch of hardware. And actually, I don't need to power this. So I only need to power these few things. So that should be able to be powered off of a USB to the computer, and then from there onto these. So I should be able to just get away with the USB power. Because also that's going to be what I'm going to be using for debug. So I'll probably just use USB power. Alright, so let's go ahead and lay out the Arduino Mega and figure out what's going on with that. And then maybe I won't worry about the screen right now. I'll just show you guys which of the pins the screen takes up, and we'll go from there. Whoops, this is the wrong project. There we go. Alrighty, so what I did is I figured out that was the 3D perspective, right? So you go view, perspective grid, and you say high grid. So figured out what that was. Okay, and then what I did is I went online really quick and found a picture of an Arduino Mega and downloaded that, and we're just going to drop that right in Illustrator, so, and then flip it around so we could oopsies. It's for a Photoshop class I took a while back. Whoa. I'm hitting shift and scaling it down so I preserve the and then this guy should be 6 inches across. 4 inches that way. So what I should have done first, oops, 6 inches that way. And then 4 inches down. this is 360, is 270. Make sure this is 4 inches. Alright. Let's drag and drop that again. As you see, we're working on Smart Charger 3. Video number 3. What the heck? This mouse is really wonky on this table. I don't know why it's stretchy. There it goes. Let me see quite a bit. Actually, I was completely wrong. It's the other way around. Is it? I think it was 4 inches. Yeah, it's 4 inches long, so it's actually... But we need to... I can even remember how to rotate in here. Oh, yeah. Transform, rotates, angle. .240. What? Sorry. Not 240. Rotate. 270. Alright, so it's supposed to be this long. Now I got to send it to the back again. There we go. Alright. Well, that's going to work for right now. I'll figure out how wide it's supposed to be. I know it's supposed to be like, I think it was supposed to be, it's like 2.5 inches. Anyways. Whoa. Alright, so we have this guy. Now what's taken up is all of these are taken. So all of these, some of these are free. Okay, so it goes A0, A1, A2, A3, A4. These are taken. So let's put those in red. And then big stroke. Maybe like a 5-point stroke. So those are taken, and then pretty much all of these are taken. From here all the way down are taken. And then, so yeah, group those together so they don't move. Okay, so all of these are taken by the touchscreen, and then all of these are taken from the touchscreen. Also, it's kind of difficult to get to some of these, but we need to get to them. We need to be able to get to them because that will
give us our best chance. So A5, A6, A7, A8, A9, A10, A11, 12, 13, 14, 15. So that is from 5 to 15, so that's 10. So basically what that means is that we could do three 3 cells, two 4 cells, and 1 2-cell or 2 1-cells, or 10 1-cell, or etc. etc. Because these are our analog ends. So with the analog ends, we'll be using those to check the voltage of each of the cells inside of the battery. So that will be the factor saying how many we could do. These are used on the touchscreen for the touch built into the touchscreen. So it'd be nice to have maybe a controller after the Mega that can allow that. And then we have all these other pins to use. So this is plus 5 volt, minus 5 volt. This is plus 5 volt, and then this is minus. This is ground. So 22, 23, 24, 25, 26, 27, 28, 29, all the way down to 53. So we have 14 to 53. So that's 9. That's 39. No, 29. No, it is 39. 39, yes. 39. 39 digital pins that we have available. Obviously not going to use all of those. And then these 0 to 13 are used for the digital pins to use the display. Alright, so we'll basically go through here and pick a few of these different colors and attach them to different places here. And then we're obviously going to have some sort of harness or something that comes off of these 5 volts, because we just don't have enough 5 volts. That's another thing, that these are covered as well by the touchscreen. So touchscreen is a standard touchscreen shield, so all of that is covered by the shield. Luckily, I have some screw shields, which basically is the shield I put underneath, and then it goes on top, and then the touchscreen could go on top of that. So we could get to these plus minus 5 volts, the VN, stuff like that. So we could get to the VN to give 5 volts off a buck converter. So ideally, the ideal case would be that we have a buck converter that comes off of 5 volts. But for right now, we'll just say that the power comes out of the Arduino. But later on, this is going to be attached to some buck converter that gets power to all of our electronics that need 5 volt. Right? So that would obviously mean that we need a few things here. So I'm going to drop the infill on this. So with this, from here to 5 volt. And then of course this is without looking at any of the data sheets. See where these go. Right. So these are all chip select, ground. Then we have voltage here. So this is the voltage output ground. Yeah, so these are the inputs. So these are just standard up to 5 volt. Let's stop doing that. Okay, so it goes voltage to ground, voltage there, and then ground. Here to GND. Oops. This to GND. And this to GND. Alright, now the ideal is that some of these could also be used for PWM, so we're not really too worried about that. So we go back here to this one, turn that back to the red. So some of these pins can be used for PWM. Not all of them. I believe it starts at number 34. I think something around there, 30, 36, or 37, somewhere around there, and then the rest could be used as PWM pins. But we don't have to worry about that. These, again, like I said, are kind of obscured. So, and these are also, you know, pins that you could use for TX or RX, transmit or receive, SDA, SEL. So what we'll probably do is just use all these pins down here for all that stuff. And it doesn't really matter where they connect as far as I know. I could, you know, try to Google the pins, but we'll do that in a second. And also another thing that we're gonna have to do is I believe that these guys are analog themselves. So these are also going to take up pins, so that means that we only have 8. So we can do 2 4-cell, 3, 2. So we have 8. So that's 2 3-cell, almost 3. Almost 3 3-cell. So only 2 4-cell, 3 3-cell, and 1 2-cell for the 2 3-cells. So something like that. So because these two guys, I believe with just one pin, it's not digital, it's analog. It's some sort of analog out. So what we'll do there is those are going to have to take up 2 of these. So maybe we'll have those over here at A5. I'll come up with a color. So I wish I brought up some of my pins that we have standard colors. But I have blue, red, because I have a whole bunch of jumper pins that will easily connect from here to wherever we need them to be, which I'll actually go get a set of those because I know where those are, so I'll be back in 1 second. I have these. These are some DuPont 40-piece jumper pins, and they should have 10 of each color. So we have red, black. Let me separate these out. Actually, no. I'll just separate out the red and the black. So we have brown, white, gray, purple, blue, green, yellow, and orange. So that's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 pins. 8 pins that we're not using for other stuff. So 1, 2, 3, 4. Wait, this is also ground. 1, 2, 3, 4, 5, 6, 7, 8. We have 8. Okay, so perfect. So we have just the perfect number of pins. All right, so that means that, wait, I said we have 8, right? 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Wow. Okay, so pick a color for each one. So let's just go down the line and pick from the top. So this one is brown. So that color. Actually, kind of more that Okay, so from here down to A5, and then the next color is white. We're not going to be able to see white, so let's do white with a, oops, this is the brown. And then we're going to go from the RH, actually let's go from O, from there to A6, and then that is going to be white. Yeah, can't see it. Huh. Anyways, yeah. There's white, gray. Okay, so then let's start with the gray. From here to pin. Start from pin 14. There's also, we have a whole bunch of other electronics that we want to incorporate, something like a thermoresistor to read temperature and such. So we're going to be using quite a bit of, eventually we're going to have to get some new colors. But luckily right now with this, we're going to be able to do most of what we're trying to do here. Oops. Supposed to be 2 point. This is supposed to be none. And this one was supposed to be gray. That color gray. 2 point. And that one, gray, purple, blue. It's like, so like that color blue. Okay. Ground, black. I don't know, because one of these are, one of these are obviously going to a different ground, right? One of these are obviously going to go up there. Oh, I just remembered I have 2 of those. Not just one, I have 2. So yeah, we're going to need quite a bit more colors actually. We'll probably duplicate these colors again. So that's what I have right now. Purple, blue, green. And then we have yellow, orange. then chip select pin is obviously here. This is going to be yellow. And this is going to be orange. So I'm sure that one of these doesn't go here and goes somewhere else, right? I'm sure one of them does. I thought these were grouped. So now I'm going to have to duplicate this. Alright. Oop. There we go. Okay, so basically a similar thing there. I could do that off camera. You get the idea. Luckily, that's pretty cool that we're able to get every one of those colors utilized somewhere. So that being said, I'm gonna have to go through and look at all of these dots to figure out where each of these ones go. Because this is the first time I've ever messed with anything that's the digital potentiometer. And that's quite a few pins, 6 pins on those. And so I'll get the documentation of those and then figure out where each of those wires go. And then I'll be ready in the next video to put those where they go. And then after that we will be ready to set up the first piece of the physical layout of the machine, and also do some prep where we run the regulator here and see it work before we before we start unsoldering anything, because we need to make sure that it works before we unsolder it, right? Because if it doesn't work, then not really any point messing with it any further. So need to be able to turn this thing on, turn the potentiometers, and then be able to monitor the what it's putting out, right? And then with that, I'll just be using a multimeter, and we'll measure first voltage and see that the voltage changes, and then see that the current changes. And then we'll go and unsolder these potentiometers off the back and get these potentiometers to work with that. And then we'll be looking at these potentiometers to see the resistance that these potentiometers are, so we could set these resistance digitally, because I think these were going from like 400 ohms or 40 ohms to 1000k ohms. So we don't need all that control, because I'm sure that these potentiometers in here don't have control like that. So basically what I'll do is when we unsolder them, just bridge the bottom with the multimeter and then check the resistance from when you bounce the potentiometer off one side, and then when you bounce the potentiometer off the other side, when it will no longer let you turn anymore. And then go from there to be like, okay, well this is the
the rate, this is what we get for the range. And then with that range, set it digitally in the software that those are the limits for these potentiometers to send, because anything else is just going to be useless. And then we're going to have to do some trial and error to be able to associate what output voltage per turn we have for that particular power supply. So every 10 ohm, every 400 ohm or whatever, it does 2 volts, or every 400 ohm it does 1 amp, or something like that. So be able to from that we'd be able to do that with the a calibration using the amp and voltage sensors. Will be able to automatically calibrate these guys. So maybe we'll have a calibrate function on there where it exports something for us, so we could edit the file so that it has that sweep between the max and the min, and to be able to record that, so we could get the most out of these potentiometers, the most finite control that we want. Maybe down to the 0.1 volt, which is would be pretty nice, 1/10 of a volt. And I'm looking at the potentiometer right now. Everything looks pretty good. Opened up the anti-static and put it in this other bag here with everything else. Alright, so that being said, I will probably I'm going to bring up the issue that I wanted to bring up in this video, which is right now I am I am living at my parents' place while I'm going to school, and my room is being constructed as being relaid out. We're putting hardwood floors in my room, in my bedroom, and my parents are getting ready to retire, so they're getting ready to maybe sell the house and move out of California. So we are laying down hardwood floors in there. So I am now, as you know, recording in the TV room, and basically all my stuff is in the spare bedroom out of my room. And long story short, I do not have anywhere to do any sort of physical film and hands-on as of right now. I could go to Tech Shop and do it out of Tech Shop. That would be a good idea, to find somewhere quiet at Tech Shop to do it out of. But as of right now, where it's nice and quiet, good lighting, all the electronics that I need, soldering iron, blah blah blah, I do not have any space here that is clean and would be the best setup for the viewer. So that room, we're painting it right now, and we're going to build a custom desk in there, a custom cantilevered out desk from the wall. It's going to be very nice for filming. It's also going to be a very bright white room, so have very nice lighting. So waiting for that to be done, that would be the ideal place to do to continue this project as far as the physical things that are not just looking at the screen here. So it looks like we will be able to get an entire additional video to talk about the libraries for this, and also the wiring for these potentiometers to these guys. But by the next video after that, if I don't happen to start programming at that point, because then we can program on the screen there. So if we don't happen to get to that point, we will need some place to do it, and maybe I might be able to make that happen at Tech Shop. I am working on the filming equipment to get you guys the best setup for watching the physical stuff, and also the best lighting, because I want it to be an ideal experience. And that is way harder to do than to set up the video recordings like this in a room. All you need is a screen and
a GeForce GTX higher than 660, which I have a 660 Ti. So this is easy to set up, but to have something that, a camera that doesn't have focus problems, and something that doesn't have parts that are out of the screen, and yet is good quality and doesn't get in the way of what I'm doing, that is more difficult. So it would be nice to have some sort of setup in that room where I could do these types of physical projects where it's not just screen capture. So that being said, I do actually have a second project that is also in the RC realm, because that's a big hobby that I'm into. And one of the places that I am taking liberty to explore in order to do some more laid-back electronics design, where I don't have to push a product out every semester. So it's kind of like a side project, so I can be able to relax and learn on it with you guys as well, and be able to teach you guys as I go along. So I have another project where it's basically designing a Wi-Fi controller using like an ESP8266 for small micro planes. So I'm also getting more, instead of getting more into the larger planes or the faster planes or the more sportier planes, I'm starting to get into more smaller planes, hand-built, hand-designed planes like that. So to be able to build a controller that uses Wi-Fi, that uses your phone, that's easy for beginners in the hobby to be able to pick up a plane, not spend a whole bunch of money on a transmitter, and be able to control a small plane as small as a 2 to 3 inch wingspan, maybe a 4 inch wingspan, maybe about a 3 inch wingspan plus. To be able to throw that and fly that inside of your living room from your phone, right? Up to something that is maybe probably anything with your phone, you're going to want to have something that is 10 inches in wingspan, something that flies really slow, some sort of slow flyer. Anything over 20 miles an hour, Wi-Fi gets dangerous, you lose signal, it's going straight, hit somebody, blah blah, etc. But to be, so that's another project where design a remote control ESP8266 that will be able to take Wi-Fi commands from your phone to be able to fly it, and from the ESP8266 be able to read your commands through Wi-Fi, be able to drive a motor, probably a brushless, so you don't actually need an ESC, you just drive it with PWM, and then linear actuators, magnetic actuators for the rudder, or servos, to be able to do that, and then get as many channels as that, the max of 4 channels. So 4 channels would be motor or throttle, left aileron, right aileron, elevator. Or it could be ailerons and a rudder, or something like that. Or maybe like a V-tail, throttle, left, right, and maybe like a second motor or something. Yeah, something like it. So I'm thinking like an ESP01, which has, you could use 4 pins, so that would be perfect. Two PWM, so you could have a maximum of 2 brush motors. So that is a project that I might substitute in for this project if I can't happen to do, if I get stuck on having to do a visual one, a physical like on project video, and I'm not quite prepared for it yet, and also I'm not quite there to do programming yet. I might substitute in that project, and then we'll start on that project, which is also a cool project as well. That's also a lot of electronics, which was originally when I came up with this, with the YouTube channel, LegitTechTutorials, was going to be programming and electronics. And then now I have, mechanical design and 3D printing and other stuff, parts of physical tech in there as well. Alright, so that is basically it for this video. We'll be looking at, next video, we'll be looking at the data sheets for these potentiometers to figure out which wires need to go up and into where those potentiometers are, and then we'll see if we can get into looking at some of the libraries we need to use, and also maybe start programming an Arduino for the Mega. And then with the first physical video, we'll be trying out this this voltage regulator, constant current, constant voltage regulator. And then desoldering these, attaching the potentiometers, looking at the voltage sensors and current sensors, and going from there. Alright, so this has been Steven from LegitTechTutorials. I thank you guys for watching. If you like this video, please subscribe for more videos like in this series and our series as well. I'll see you guys in the next video. Thanks for watching. Take it easy. Peace.